Let's go to LeetCode 2831. Find the longest equal subarray. And for this question, it gives us list of integer nonce and integer k. So you can delete at most k elements from nonce, find the longest possible equal subarray. So what is this equal? Is that all of the elements are equal, right? So we still thinking about the sliding window, left, right. As long as we have the left minus the right plus 1, right? We count the maximal frequency in these numbers, right? As long as this one smaller or equal to k, then we move the right pointer. But this is greater than k, right? We move the left pointer one step. So we know if we have this window, right? We have the maximal here. And in the next step, if we have this kind of formula is greater than k, right? That means the character on the right must not be the one which is the max character. Otherwise you will see we can still expand. That means the different characters is still small equal to k, right? So if it is the same as the maximum one, we can expand. So that means this must be a different character, right? So in this case, we'll see this maximum value is the maximal size of here, right? So if it doesn't meet the condition, then we move the left pointer one step to the right. At moving, right, it's possible that this kind of condition still doesn't meet, right? But we don't need to care about that. So after move that, it's possible that this still smaller equal to k, right? After we remove some kind of condition. Then we can expand the right pointer again, right? So during the process, we expand the right pointer, we count the max. So in the end, we just return the max. So let's begin to write code for this. We have max count. Okay, max count equals to 0. Right equals to 0. Left equals to 0. And what else we need? The type n equals nums dot size. So let's say for right smaller than right plus. Okay, so the maximal we need to have a data structure to store the counts. So we are using map integer map equal to new hash map. So we'll say map get for default nums get right. We can have put map with our default we can have the right number instead of right number, okay, equals number skip. That's right. Right number it default right number 0 plus 1, right? So only it's only possible that because during this kind of process, only this counts change the number, right? This numbers counts. I mean, this value, right? Change the number. So we'll say the max counts equals max dot the max count and the max get that number. So let's say if max count is greater than k, right? If it is greater than k, what we need to do is that we have left plus plus, right? And we need to update the left one, right? So the map put now the left number first numbers get left. Okay. Put the left number map get left number minus 1, right? Of course, if it is equal to 0, we can remove that from the map. But this does, if we don't remove, it's not a big deal, right? So in the end, we just need to return this max counts. That's enough, right? Because the max count here, what we count is so far the max counts we made. So this this is not max count. That is the one to delete will be sorry, should be right minus left plus 1 minus max count, right? So this is the one to delete. Yeah. So the things that we had mentioned, this max count will be the one the value that will be at the right at the index right so far the maximum count we made, right? So even both left and right shift to 1 space, right? This max count this value is the 1 so far what we made, right? As we mentioned, if this number is the same as the maximum frequency one, this condition will never happens. But if it's different, then we'll compare if this is greater than k, right? Then move left. But this value has never been changed. The new window, it may not have this kind of counts satisfies, but every one shifted 1 step to the left. That is the max count we made so far. Right. So for the next loop, if on the right we have we can count the max count again, right? And in the end, we just need to return max count. Simple nouns. Left. the time complexity will be O(n). So we use for and if we don't use while, right? If we have while, we need to n multiplied by the different characters category numbers, right? So this one, you see, the number length has 10 to the power 5, so that will be 10 to the power 5 multiplied by n if you use while. So we can use this kind of for if, right? That is some kind of greedy. That is if condition maintains, then we move to the right window. If the right index, if the condition valid, then left shift, just shift one to the right. We know this kind of condition, in this window, the condition may not satisfy, but the previous state is satisfied, right? So this is the key point for this question.